In this video, you'll learn another way of using links. It is assumed you've watched the first video, which talks about how to design and build links. In that video, we used links to do process shifts. Let's assume I'm evaluating a machining process that uses a single tool to produce 6 holes. I could look at each dimension item and get an idea what's going on in the process. Somewhat cumbersome because I have to look at all 6 dimensions. It would be nice if I could summarize that information in one dimension item. I'm going to show you how you can build a new dimension item from existing data using links. The first step is to add a new dimension item that will receive the data from these 6 diameters. So let's go to the edit mode and add that new dimension item. Let's add the dimension item into this group. I'll click on the Insert Dimension button. Now, the way this is going to work, when a part is measured and this reaction plan processes the data, the last part, the diameter, the 6 diameters of the last part will be summarized in this dimension item. So we have to configure the properties accordingly. Let's start by configuring the general properties. First thing I'm going to do is give it a name. We'll say summary, 6 holes, last part. Actually, it'll be summary 6 diameters. Last part. The type of dimension will be normal. The data source will be set to link. This is really important. Usually it'll be set to default, but the data is going to be received from a link, so you must tell it the data source is a link. The message when no rule violations are violated will say no adjustments required. We'll leave this the startup graphics view to detail for now, and the rest of the properties for the general tab we'll leave alone. Let's choose the nominal/tolerance limits tab and fill out the entries here. Now, since the tool is machining the same tool is being used to machine the 6 holes, we know the diameter and the plus and minus tolerance for each of the holes is the same. So we need to tell it what the nominals and tolerances are. We could choose an entry from the table or manually type it in. I'll just pick one of the entries in the table. Now the data is going to be received from a link, so you don't have to tell it where the actual column of data is located, because it really doesn't need that information. It's going to pull that information and it's going to receive that information from a link. So let's fill out the entries for the last run reaction. For the number of items to calculate the last run statistics, we'll set this to 6. Because we want to calculate the average. We only care about the last 6 items because those last 6 items represent the diameters of the 6 holes. So we'll set this to 6. Go ahead and set our percent of tolerance criteria to plus or minus 0.8. Put in a message. Do the same thing for our out of tolerance rule violation. And for our process reaction, we'll set this to 6 parts as well, and leave the rest of these properties to set them to the defaults. I'll save those changes, and that'll take care of the properties necessary to receive the data from links for this dimension item. I'm going to go ahead and move this dimension item to the end. So move this down. And let's go to the view mode. I'll save this solution. And watch what happens when I measure a part. You'll see that data went into the 6 holes. However, nothing went into the summary 6 diameter last part dimension item. That's because we haven't set up the link yet. Let's go ahead and do that. So let's go back to the edit mode, and let's open up our link menu, or I should say our link window, and configure the links accordingly. The goal is to get each one of the diameters to be, the data from the diameter to be copied into the summary dimension item when new data is received from a new part measurement. The link will be the mechanism that does the copying for you. Now, there are a couple of different ways you could set the links up to do this. You could set up 6 individual links, and contained within each one of those links you can have the triggers and the actions that handles the copying for you. Or you could have one link that does all of the work, that does all the copying. You can decide how you want to attack it. I'm going to show you how to set up one link that handles copying all 6 diameters into the summary dimension item. I'm going to assign a link to one of the diameters. It really doesn't matter which one. I'll just pick one diameter. Click on the add button. That'll add the link. So now I want to set up my triggers so that no matter what happens, when new data comes in, it executes. So to do that, I need to select all and select all rule violations. And what will happen is when new data comes in, it'll execute the link. The link actions will be 6 assignment statements. Each assignment statement will simply copy the data over to the summary dimension item. So I'm going to start by copying to the summary 6 diameter last part dimension item, and I'm going to copy to the actual. It's assignment statement, and the variable will be a dimension, and I'm going to pick the diameter 6, and it's going to be the last run average. And now click on add new, and so that'll take care of doing the assignment statement. But now the assignment statement is going to assign the data to the actual value for the dimension summary 6 diameter last part dimension item. I'll do the same thing for diameter 5, same thing for diameter 4, 3, 2, and 1. So when this link executes, it's going to pump the 6 diameters into the summary dimension item, and it's going to be in reverse order. So the sixth diameter will be all the way to the left, and the latest diameter, the hole 1 diameter, will be all the way to the right. Let's go to the view mode, save the solution, and we'll run one part, and let's see what happens. You can see that the diameter data was entered into the 6 dimension items, and there were 6 pieces of data entered into the summary 6 diameter last part dimension item. The link did its job. It copied the data over to this dimension item. If I hover over the actual value, this should be hole 6 or diameter 6. You can see it's 0.7504. This is diameter 6. The last run average is 0.7504. So it worked. This is hole 6. This should be hole 1, 0.7503, 0.7503. We now have a dimension item that captures the 6 diameters. We really don't need to see the 6 diameters displayed. I mean, we need them, they need to function, however, we don't really need to see them. You can mark the dimension items as auxiliary. If you mark them as auxiliary, then they'll function, however, they will not be visible when you're in the view mode. So let's go to the edit mode, and I'm going to change the diameters so that their type of dimension items are set to auxiliary. So if I'll highlight all of these using the quick dimension edit tool. I'll highlight all 6 of the diameters, change the type to auxiliary. It's telling us we've got a link. Do you want to execute the link? No, we don't want to execute the link. So since we're in the edit mode and you're in the summary view, you'll see them, but they're grayed out. Now if I go to the view mode, you'll only see the summary dimension item. So if I measure some more parts, you get to see the data flowing into the 6 holes being captured in the summary dimension item. This dimension item gives us statistical information of the 6 holes of the last part. If we were really making adjustments to the process, you really want to look at more than just the last part. You want to look at a stream of parts. So how do we accomplish that goal? Well, it's really simple. You simply add another dimension item, make the data source of that dimension item a link, and you take the average of the last part and you pump that into the new dimension item. So let's return to the edit mode. Now we could insert a new dimension item. Instead of doing that, I'm going to copy and paste the dimension item we've been working on. That way we can save a little bit of time. Now I want to make sure that we pick the right one. So we want to work on this one. Let's change the properties of that dimension item. We're going to call this diameter summary for the name of the feature. The data source is still going to be a link. The nominals and tolerances is still going to be referencing the same cells. The last run reaction, we're going to change this. Instead of looking at the last 6 items, we're going to look at the last 3 because we want to make adjustments for the parts. Each item represents a part for this particular dimension item. The percent of tolerance rule violation, the out of tolerance rule violation, we'll leave that alone. And for the process reaction, we'll set the maximum number of items to 30 because we'll keep the last 30 parts. Let's move our diameter summary down one so that it's actually at the very end. Let's go to the view mode. Go ahead and save this. And we'll inspect a part. You'll notice the summary for the 6 diameter last part that updated. However, the diameter summary did not update. That's because we haven't set up the link yet to push the data from the average of these last 6 diameters over to the diameter summary dimension item. So that'll be our next step. We'll return to the edit mode and we'll pull up the link window. I'm going to add another link. This time I'm going to attach the link to the summary 6 diameter last part dimension item. I'm going to have that executed after the 1 diameter link. So I'll click on that link, fill out the triggers and actions. Now for the triggers, I want to select all, and so the link will execute immediately after the 1 diameter link. For the actions, it's really quite simple. I want to assign a value to the diameter summary. That value is going to be an actual value coming from an assignment statement. And all we have to do is use the last run average of the summary 6 diameter last part dimension item. And that'll assign a value to the summary dimension item. I'll say OK. Let's go to the view mode, save that solution, and inspect another part and watch what happens. This piece of data is the average of the 6 diameters of the last part. If we measure another part, you'll see another piece of data for the next average. Measure another part, the next average. Measure another part, the next average. So now we are getting a stream of parts. We can now appropriately put in the instructions for the process as opposed to just looking at each individual part. We're looking at a stream of parts, which will give you a better way of evaluating the process. This example uses simulated data to emphasize how to use links in a different way. If this were a real example, you may use this dimension item to check the quality of your tooling and this dimension to check the process. So what do I mean by that? Well, let's assume that, let's say your range was excessive. You could have a range rule violation set up so that if the range is high, the instruction may be to check or replace the tooling. If the range is okay, however this is drifting to a percent of tolerance out of tolerance condition, you may want to replace the tool because it's just wearing out. In that example, if you're going to replace the tool because your range rule violation occurs, you probably don't want to send the data over to the diameter summary. You probably don't want to use that in this analysis. You can control that using your link. Simply set up your range rule violation in the summary 6 diameter last part dimension item and uncheck the trigger for sending the data over to this diameter summary if the range rule violation occurs. Links are very powerful. You control the order in which they're executed based upon the order in which you place them in the link list. You control if they execute based upon the triggers and the actions that take place. It gives you the power of programming without generating any code.